All right, this video here covers explanation of questions 1 through 5 on the review. The first question is asking about inverses, and as a reminder, for inverses, if you think about your ordered pairs, x's and y's flip-flop, and so that's exactly how you want to solve for a and b. You want to flip-flop the position of where x and y is. And notice in part C, there is no equation. You're just given ordered pairs. So this should be an easy one here. For C, you just flip-flop. Instead of 4, 9, you have 9, 4. Instead of 6, 13, you have 13, 6. 8, 17 becomes 17, 8. And then 10, 21 becomes 21, 10. So you can see there how the x and y values flip. That's what we did over here for A and B. You flip where the x's and the y's are, and then you solve for y using inverse operations. So looking at part A, to solve for y, we're going to add 4 to both sides, and then divide by 3. So our f inverse of x will equal x plus 4 over 3. And then for B, again, to get y by itself, we'll start by adding 5, doing inverse operations. And then to undo division, we multiply. So we will get f inverse of x equals 2 times the quantity x plus 5, which becomes 2x plus 10. You can check that you've done these correctly by comparing some ordered pairs, and you'll see that their x and y's are flip-flopped. Now for number 2, you're just using properties. Log base x of x, anytime the base in the argument matches, it equals 1. Log base x of 1, no matter what the base is, you have to think, how do you get 1? X to what power equals 1? That's the 0 power. Here, you can think of your power property, and log base x of x is 1, and that's why it's 3. But that is also a property. You don't need to go through and do the work if you remember the property. And then for D, when you have this, when the log is in the exponent, the base and the base matches, it just equals your argument. So all of those are properties. Again, if you forget them, you can always try converting to exponent form. With 3, you're just typing in log of 12, 1.0, oops, why is that not working? 1.079. So that just means 10 to that power equals 12. For B, you're going to use the ln button, so you do ln of 3, which is 1.099 if we round to 3 decimal places. For C, you either have to use the change of base formula, which means you're going to type in log of 72 over log of 3. Unless your calculator can do it for you, then you just type math alpha math, which brings up the log button. You put in the 3 and the 72, and it will give you your answer. This change of base formula is only if when you do math alpha math, if nothing comes up. Some calculators don't have that. So math alpha math lets you change the base, okay? And that gives you the 3.893. And then ln of 0, if you type it in, you get an error, and that's because it's undefined. Because 0 is not in the domain of logs, okay? If you think about this, you can never take e to any power and get 0, okay? Nothing that you can raise e to will give you 0. And so that's why it's undefined. 4, you're just rewriting. So we currently have this as log base b of a equals c. So rewriting that in exponential form, and you need to know how to do this to do all the solving problems, you will get b to the c equals a. Remember, the base in the log is the base in the exponent. Logs equal exponents, so that's why the c becomes the exponent when you rewrite it in exponential form. Here, 5 squared equals 25, and that's one we can check. We know that 5 squared does equal 25. Here, same thing, 8 to the 1/3 does equal 2, and again, that's one we can check. 8 to the 1/3 is the same thing as the cube root of 8, which equals 2. You can also plug it in your calculator and you see it equals 2. So the ones with numbers, it's nice because you can check them. Now for 5, we're going the other direction. The base of the exponent becomes the base of the log. Logs equal exponents, so the c goes here, and then all you have left is the a for your argument. So here, base of the exponent becomes base of the log. Logs equal exponents, so that equals 3. 125 becomes our argument. Here, base of your exponent becomes base of your log. Logs equal the exponent, so that's 4. All you have left is the 1296. And all of those you can check on your calculator. Not A because it's variables, but for B and C you can. You can do your change of base formula, or you can do math, alpha math, and you'll see that you have converted it correctly. All right, that is it.